Okay, I wanted to make another video that doesn't start with me saying okay. Anyway, things I'm working on. This is just going to and not saying like all the time. This is going to cover some of the things, the highlights that I consider for. This is generally a software development lifecycle chapter. So, software development lifecycle, or SDLC, is a big subject you learn about, especially go on in computer programming, computer science, IT probably as well. Um, this is called system acquisition and development for the chapter, but it's really kind of a software development lifecycle chapter. So I'm going to be guided by the slides. I'm going to skip a bunch of the slides because a lot of stuff, frankly, you don't really have to know. If I skip a slide, I'm not saying you definitely don't have to know it, but I'll just put it this way. There'll be a study guide, and you'll know the topics that you need to focus on for the exam 2, which is April. This is not going to be a generic. I'm going to have to redo this one because it's going to be different for each semester. I'll just say exam 2, actually. Maybe I can get away with reusing this. So exam 2 is still a few weeks out, and it's in bright space. You can see what it is. There'll be a study guide before exam 2, but this is covered on exam 2. I guess when you're working on your Python program, it's not like a software development lifecycle kind of project. It is software, technically speaking, but it's just a small little toy program that you'll be making. You won't be concerned with most of the things. Some of the things you got to do some planning and that sort of thing, but it's not the same thing as software development lifecycle. That would be something like a game. Most of you guys are most familiar with it in the context of video games. If you play video games at all or know anything about the development of those, there's a lot of I'm sure there's specific things for game development that are probably outside of the generic software development lifecycle that we're covering here. I don't work in the video game industry, so I'm not sure exactly what they do and how they do it. But there's going to be a lot of overlap at the core of what goes on. Also, yeah, I was going to say, this will date the video if I talk about Cyberpunk 2077, but you can see there's also like ways that it can go wrong. There's a lot of opportunity for failure in this process. All right, so let's go through the slides. I've got some things pulled up that I'm going to show as we go, but I'll say this in the slides. There's two main things to look at here, two main ways of looking at how to do software development lifecycle. There's the waterfall model, which is always classic. Probably 20 years that I've been like in this environment or longer, waterfall's always held up as like, this is the way it used to be done and this is not how you should do it kind of thing. But I tried looking for statistics. I'm not sure how many people still generally follow the waterfall model, or by accident even. Sometimes like you'll try to do a different system but it turns into the waterfall model. I'm going to say it this way. Waterfall is kind of and I'll explain what waterfall is shortly, but it's kind of the natural way to do things in a way, but also not natural. Like you would never do a strict waterfall in real life probably, but you would kind of like, water flows downhill, right? It's sort of the same idea here. Waterfall model just kind of feels like the right way of doing things, and it was imported in from other industries like manufacturing, physical, like you're making an object. That's where the waterfall kind of came from and was adapted to software development. And then there's like, that's compared to like the agile. I'll try to not say it the British way. The agile methodologies, principally Scrum. There's a few others that fall under agile. But Scrum is the main one we'll be comparing to. So we'll describe what all this means here in a minute. All right, so this is, you should know all these things. So, of course, there's the whole question of whether you buy versus build. If you remember the business intelligence, I think it was, there's a hint for the exam I want to give you here, but I have to like review myself just a second. Yeah, if you want to develop business intelligence software for your business to be redundant, repetitive there. You could buy Cognos by IBM off the shelf, right? Cognos. Or you could develop your own business intelligence. That latter is almost like you'd have to reinvent the wheel in a way, and then modify that wheel to your exact needs. So, but yeah, the pros and cons here, these are pretty obvious, right? Like if you buy it, that's quick. You just buy it. There's probably also an implementation phase in there that you can't just buy something and just push a button and it works, right? You have to like integrate it into the system you have already, train employees on how to use it. For instance, Navigate would be an example of this. You guys are using Navigate. I think the faculty still hasn't been fully trained on Navigate. We have a different way of looking at it. You have the app on the phone. That's generally not how we look at it. We look at it from a web, my Pellissippi kind of entry points, kind of strange. So even if you buy something off the shelf, right, Navigate is obviously it wasn't developed by either Pellissippi or the Tennessee Board of Regents, right, TBR. It wasn't developed by anybody in-house. It was bought. It was a contract, low bid, whatever. Same thing with Brightspace and stuff like that. Brightspace was actually about to be Blackboard won the bid. I don't know if I'm supposed to talk about this. I didn't sign a non-disclosure. Blackboard won the bid for the learning management system for Pellissippi, but there's been some snags there, so we're going to have Brightspace for a while, which is fine with me. Because again, like my whole point about bringing that up is that when you bring Blackboard in, and Blackboard's been around for a long time, so there probably are some faculty who know how to use it. I don't. I've used Moodle and Canvas in my past, which would probably been possible options. Moodle's open source though, so regardless, you buy it off the shelf and then you have to like train and integrate it into what you're already doing. But it would be cheaper and faster. And then building it, customized anything in life tends to be a lot more expensive, and it's going to be a long process. So that's that table knocked out. All right, so waterfall. These are like the phases. These will be called different things in different. If you look up waterfall model or SDLC, software development lifecycle, if you look up those terms, you'll find slightly different names for some of these things. Like requirements will be in here somewhere. Maybe requirements is considered to be underneath investigation. It depends. Maybe it's an analysis actually, but you'll find different names for these things, but they're generally the same. So you got the initial period where you think of the idea what you're going to do and find out whether it's do I want to do this here? Or do I want to do it on maybe we'll do it on one of the later slides. So investigations are where you try to figure out what the need is that you're trying to fill with this. Say it's a piece of software you had to develop to do, I don't know, handle clients or vendors or shipping or whatever it is. Or manage your classroom, right? If we were going to build our own learning management system in Pellissippi, we'd have to investigate what are the exact needs are, the requirements, and that would involve like talking to end user all kinds of stakeholders, like where the students would be stakeholders, the faculty would be stakeholders, maybe the administration, arguably, depending. I mean, for instance, financial aid would need to know your last date of attendance if you drop out, that kind of thing. So there could be different levels of stakeholders, and you would interview them, and then maybe look at the current system, see how things are done, what process, what's not working right now that we want to fix, that kind of thing. That's the investigation. And then somewhere between investigation and analysis is going to be finding out the feasibility. Like, is this something we really want to do? Is it going to cost too much? Is it going to take too much time? What's the scope? What should be included in this? What are the actual requirements for us to like declare this to be done, satisfied thing? Then what are the needs we need to meet in order to call this a success? And then you kind of like do the design, the planning stage, where in terms of software, you would like decide who's going to be on the team, what tools you're going to use, draw a bunch of models, like if there's a data component, like how the database would work, and do the ERD for that. UML diagrams, unified. I still haven't looked up. Let me do that real quick. Unified modeling language. let me just do an images search here and show you what a UML diagram looks like. There's different components to UML diagrams. Here's one. So these are like use cases where you show a person and this is the things they're going to do. And there should be other things that kind of look like ERDs in a way, but yeah, I don't see that. UML class diagram, let's do that. Umbrella Academy, I haven't even watched that yet. Class diagram. This is if you're, for you guys who've had some object-oriented programming, you might know what a UML class diagram is by now, but just kind of an example of what cookie kind of thing right here, talking about what a class is. So this would be a class diagram. So in our software program, we'll have a class called shape, and it has a private variable called length, and then you have these public, they're called accessors and mutators. They change what the value of this is. So this diagram is just telling you, it's kind of like an ERD, entity related. It's kind of like an entity. Entities and classes are very similar kind of concepts. The only difference is these are things that the entity or the class is, and these are things that the class does. So that's UML is like a combination of a bunch of these things that show how the long and short of this is stuff that you would do in the design phase. You would have these UML diagrams, ERDs, data flow diagrams showing how the data moves from one piece of your software to the other, that kind of thing. And then construction is the actual coding. So you planned everything out. You planned out what your algorithms for your individual parts or whatever, and then the team starts working. And at some point, the team will finish, and then you would integrate it into the current system and test how things go. And there's different kinds of testing. There's like volume testing. Volume testing is when you throw a bunch of users at it to see if it crashes. Integration testing itself is where you like add pieces of the software and see if anything breaks, and then add more. System testing is when you have the whole thing integrated and you want to see if, and then just run it as a system. Like you'll usually have a dev and a production division here. So in the development area, you fully integrated it and you do system testing to see if the whole system still works. Unit testing is unit testing is a long subject to get off on in programming, but it's more at the defined level. So you have individual sort of procedures or actions that you would test, and there's something called test-driven development where you actually create the unit cases, the unit tests that you're going to do before you start writing the programming, and then you write your programming in order to pass the tests. So if you imagine like any process you do in your program could be divided up into lots of little tasks, functions, then you would test each of those functions. You would write your code you figure out what the function needs to take as input and what it needs to produce as output. You write tests for that, and then you write the software to pass those tests. And once you've passed all the tests, if you've ever done, what's it called, JUnit in Java, it's a satisfying feeling when you do it. From personal experiences, you run, and then all your tests are red, and then you start writing code, and eventually, more and more turn green until they're all green. So that's the unit testing. This is the very finest level. Integration again is like taking a big piece, adding it in, and seeing if it works, but not the whole thing at once. And then system is the whole thing. And in the volume, there's other testing I'm probably leaving out. There's volume when you send a whole bunch of users at it to see if it crashes, and then just user testing in general to have the end users use it and see if it satisfies their needs. That's all kinds of testing. Then implementation is when you actually just say, okay, this is what we're using now, and you do the switch over. It's called a cutover is the term for it. These things that I'm pointing out, by the way, like if I say the name like that, you probably won't remember it for the future. So cutover is the point in time, the crisis point, when you go from the old way of doing things to the new way of doing things. So let's get back to this waterfall. In general, though, like I talked about each of these steps. And we might refine it as we go through the slides, but maybe they put some things in slightly different stages than I have. But the main thing you want to remember about waterfall is this, is that usually to get to this stage, for example, you have to complete this stage, something called deliverables. So this stage will have deliverables. It will have like proposal documents, whatever, like this is feasibility. That's probably more in this phase actually, but requirements documents would come out. So you'd have these things called deliverables. Think of deliverables as what you need to have complete before you can start the next stage. And then this will have output, right, which are called deliverables. This might be the scope and the budget and that kind of thing. Feasibility. And the output of this might be just not to do the rest too. That's always a possibility. Either not do the rest, or if you do get the green light, then you go to the next step. So think of it that way. Again, it's called waterfall because you always go downhill and you never go back up. Now, you'll notice this has lines that go back as well as forward, and that's because hardly anybody ever does waterfall. It even says it here, progress flows steadily downward like waterfall through the various phases of it. But it doesn't talk about this arrow that goes back. And it is possible to go back, but then you're not strictly doing waterfall. So you're doing some kind of slightly modified waterfall. So the analysis might be like, oh, this budget, there's too much. This is going to cost too much. So you go back and investigate if you can do maybe like a smaller scope, right? And so there's usually a little bit of backflow in this. But once you get down, the further down you get, the more costly it is to go back. But especially, this is what made me think of it. The implementation, you might find some problems after it's fully turned on, so you might have to do a little bit more testing. And maintenance is usually included in here too. So like if you have contract to maintain the software after you completed it, fix bugs that come up and that sort of thing, that would be also in this last stage. And there's a little bit of backflow, but in general, a strict waterfall means it's linear. It's a sequence. One thing follows the other. So the point of all this is that waterfall is very rigid. It's not forgiving. And it's, I don't know, I want to say it's slow, but the penalty for error is high the farther you get into it, because you don't go back. All right, that's waterfall. And again, that's kind of thought of as like the standard default way of doing things. So think about it in manufacturing, right? Assembly line, this sort of waterfall, I guess. Not really. It's a component. That would be in the construction phase. So it would be like a mini waterfall inside the waterfall. But yeah, you come up with the idea of a product, figure out what the budget, whatever it is, design the product, build the product, see if the product, like a car, like you're designing a new model of car, right? Or let's say something with a Wankel engine. Right now, it's only RX-8 was the last one. I don't know if they're making any right now, but see if it works. Let's say a self-driving car. Test it for a while on controlled conditions, and then like maybe release it and see. I don't know. There's no fully self-driving cars yet, right? There's Tesla stuff, but as a matter of fact, I've got a loaner right now for a while. My car's in the shop, and I was surprised that the cruise control, like it can sense that the car in front of me is stopping, so it brakes automatically. It's kind of cool. It's a Mazda CX-5. I kind of want one. Heated seats. It's much nicer than my actual car, which is a Miata, which I love. I love driving a Miata, but I know what some people will say, but yeah, I don't care. You can criticize it. It's so fun to drive. Anyway, it's tangent. Yeah, I had to have the engine replaced though. Okay, you don't have to hear about my problems. So yeah, here's what I was saying. I was telling you like the pros and cons of waterfall. Let's see if this slide is. So formal review at the end of each phase allows a maximum. So yeah, this is another thing. It's the management, the project managers, right? The people higher up. You've got grunts working on like if it's programming, right? You've got the grunts working on the front line. The managers might not even understand programming. Ideally, you'll have like a software engineer in quotes. Software engineer in general is just anybody who writes programming for an industry, I guess. But another way of thinking of software engineering as sort of more high is the stuff that we're talking about, like how to manage software projects. That's software engineers. So some software engineers might not actually write the code, but ideally they should understand something about writing code, something about programming, and then they can manage other programmers and organize the project that you're working on. Ideally, that's what would happen, and then maybe above them, there's people who don't know programming that just want the product. But the whole point of what I'm trying to say here is that in waterfall, typically the management has very firm control, which is shown as an advantage here, but it's actually, most people would say, especially the people writing the code, would say that's a big disadvantage. So user get assessment meets the needs is understood by the developers. That's also true. So what's being left out here is like at the initial investigation stage, you might have some interviews with the end users and that sort of thing, a small amount of time, and then like you write out here, this is what the users want, and then you just go off and do it. And like at the other end of the tunnel, when you're in implementation and testing with the users, they're like, this is not what we wanted at all, right? So that's a big disadvantage. So documentation, this is sort of another thing that is compared to other models. It's like there's a lot of documentation that details the extreme nitty-gritty detail how everything works. But again, this is kind of related to the last thing. It's like it's in the way that the software developers understand it, and not necessarily how the users might have. And the users might have like not thought of things, right, that would come up in the building process. Like if the users had watched all along, they'd be like, wait, you're going the wrong way. We don't need that. We need this, right? So that's the disadvantage side of that. Approach produces many intermediate products that can be reviewed or measured products. So these are the deliverables I was talking about. So you investigate, there's a document. You analysis, there's a document, and then the planning stage, whatever they call it here. What do they call it? That's going to make me design. They call it design. At that stage, have a plan that comes out. There's a deliverable. So you're going to review those before you go on the next step. Is this, we're done with this stage before we go to the next? Are we sure? Right, that's kind of considered a pro here, but this is going to make more sense when we compare it to one particular other model, especially of how of this. But the users, it's not like, are the users going to understand the planning documents? They're not going to know what a UML diagram is, right? They're not like, you might try to explain it to them, but if you have the users involved at all, which you usually don't. After the first stage, you don't usually have the user the first and like the last, right? You ask them what they want, make it, and then through several stages. Go back to this. You talk to the users here, and you will have some user involvement here. You don't through these you don't, right? So they're not going to understand the analysis. They're not going to understand the design documents. If you show them the program code without actually setting it up for them to test, they're not going to know what it is. So they don't have a lot of opportunity to give you feedback about whether you're doing things wrong in the waterfall model. All right. So this is telling you the steps of each. I kind of briefly went over them. I want to allow you guys to look at these, but this is more detail, and this is their view too. Think of this as this is a waterfall model that we're looking at as in terms of these slides were developed in a certain way and we're the end users, right? So they might be leaving out things that we would think that need to be in whatever. But this is what I'm trying to say is that if you look at a different person who proposes this, you might find slightly different things here. But in general, these are going to be the same in each step. So then, this is the feasibility analysis. I put this in an analysis phase, I think. Preliminary, they say, and then the final, I guess. So, hey, this usually costs a lot, versus analysis phases. Our accountants and other experts, business intelligence, whatever, have finally examined this, and they know a very close to the probably correct price. So it's like general ballpark versus like the actual details on the feasibility in the next stage. So And I would say recruit team leader and team members. I feel like that would come later in some versions of the waterfall model. Maybe a preliminary. I would call this preliminary too, and you wouldn't really know until the design phase who exactly you need, but whatever. Develop. So this again, budget. I feel like the budget's going to be more like the second stage, and these are just some examples. These are some examples of, this is a particular project that somebody might be doing. They're showing how it might be divided up. Technical feasibility. I'm trying to remember. There was a term for that that you might need to know for the test. I don't think that's actually on there. But it's just showing you different kinds of feasibility you have, whether, you know, it's possible to do with current technology. Can we afford it? Is it too risky legally? Like, are we opening ourselves up to liability? Will the end users like what we're doing? That's the thing that's a big thing, really. It's kind of like thrown off here, but I mean, I guess it's listed lower down. I feel like it might be number one is what I'm trying to say, because like if the users don't like it, sometimes that's what you've done the whole process and you've done the cutover where it's actually being used and the users hate it and it just makes things go worse. That's really bad. And of course, schedule. Like, can we do it? And this is game programming, right? Or video game programming. Like, it takes years. So, all right. Risk. Also, you should weigh the risks all the way. Risk legally, risk schedule, risk. Like, are people going to even be interested in this game? Is the technology we're using to develop this game that kind of overlaps with technical feasibility? Is it going to be outdated by the time we're, you know, something new going to come along that makes nobody care about this? Maybe a new way of playing video games, just in general, where they put a chip in your brain or something, and like nobody cares about consoles anymore. So there's all kinds of risks you need to assess along this whole process. And this is what I was showing. These are the possibilities of. You can continue, you can drop the project, and then redefine project and redo investigation. This is showing that there's a backflow in your waterfall. And again, a strict waterfall, which hardly anybody ever really does. But it's, if you just want to start with like the clean, pure definition to build off of, in a pure waterfall, you wouldn't go back. I guess you would start a whole new waterfall, right? If you re-examined, and you could think of it as that way. You restart. But this is showing where you can like maybe go back to the investigation stage before you come back. So these are the three possibilities. And again, the one that goes to the left is kind of like, in my opinion, not strictly waterfall, but again, in real life, nothing ever goes to the exact specification that you're describing. So waterfall's hardly ever done in a pure state. All right. So they're showing, you know, this is like when I say the deliverables, it might be like a book like this. This is what we propose, and this is how we think it might be, you know. So something for people to read and evaluate where they want to go to the next step. All right, so let's fast forward a little bit. I feel like we're sort of talking. We've got to the point where I kind of want to move on to the next one, but let's make sure before we go any further. I mean, data flow diagrams, these are like, this is showing you at this stage of the process, like formalizing requirements. And then they show you like they've got, this can be broken up into all kinds of different ways and different strategies of dealing with these different things. But this is where you categorize according to importance, the requirements you want to meet. So, like, we definitely have to do this in our program. We really want to do this, and this thing, we can take it or leave it. It'd be nice to have, but if it doesn't work out, it's okay. So, and this is showing you a data flow diagram. So again, I feel like this is more like the analysis / design phase, but it's just showing how things would progress through whatever this particular thing you're creating is, right? And if you've worked in industry at all, you sort of have a sense about this. So customer generates an order, and there's a whole process where you're checking the status of the order, and maybe it makes a request. It's a product, so you have to check the warehouse and then like handle shipping, and of course it costs money, and accounting has to so this is just showing all the different ways the data flows through this particular project, whatever it is. Here's the ERD. You guys know what these are already. So salesperson serves many customers, customer places many orders. Order, I would say, this has got invoice down here. I would say an order generates an invoice, and the invoice has many line items, and a product could appear on many line items. So yeah, each invoice. So this really, depends on how you define these things, but an invoice would have line items on it usually. But all these line items would be over several invoices or several orders. So maybe you can make arguments for different, but anyway, you get the idea. This is a entity relationship diagram. So this is how you would store the data about, maybe it's for the same thing where you've got a customer buying stuff. This is how you would store the data. This is how the data flows, how information and processes and procedures flow through the project or whatever it is you're doing. And this is how the data is represented, like the meaning of the data, how the information is stored. All right, so prioritize requirements. We'll just fast forward to that. Again, you need to do the reading as well, just kind of highlight things that I think are really important. So yeah, so recruiting a team, designing a user. So UI is a big thing. UX, UI, user experience. Human-computer interaction is the general term for this big thing. UI, UX is usually more focused on individual programs. Human-computer interaction is kind of like this. It's like the computer science. If you think of programming is when you actually work somewhere and write code, and computer science is where you study how problems are solved by computing machines, then UI, UX is kind of like the writing of code and the practical side of it. And human-computer interaction is the science of studying how humans interact with computers. So that usually, the principles developed in HCI are expressed through UX and UI. And I could go on about, because I was a TA in a graduate level course on human-computer interaction at Georgia Tech, so I could go on forever about this, which I'll avoid doing, because if I start, it will go on forever. But anyway, so this is kind of like showing you some design stage concerns and a breakup of how different things you need to do at the design stage. And then you have a deliverable for the next stage, and so on. And this is like the code. This is where you actually write the code. This is called the construction stage in that flow diagram. I want to say flow, that waterfall diagram, way back. This was the construction stage. This is where you actually build. Sometimes I'll call it implementation. I guess implementation is more like you're done and you're trying to make it, implement it into being used. You could also, there might be a waterfall model where you see the building construction stage called implementation, because that's where you design what the code should do, and then you actually write the code. So you're implementing the design is the idea there. But so there might be a little bit of variation in those terms, but here it's just called construction. So this is the unit testing. So ideally forces an individual program to execute all of its various functions. So this is at the nitty-gritty level. This is what I talked about this before, unit testing, where you write the tests for maybe each literal function in a program. I don't know how many guys have coded, but you know what a function or a method is. You write all those out, and you write tests for them first. The order of that, whether you're doing test-driven development or not, if you're doing test-driven development, you write all the tests first. And there's usually off-the-shelf programming products that you can do to write those tests. Then you write your programming, your code to pass the test. That's test-driven. That's TDD. And there's variations of that. I don't want this a whole realm to get into. Or you could just write the code first and then test it, but you would test each function. That's unit testing. So at the really nitty-gritty level. Uh, all right, so these are different kinds of testing. So it says it involves linking all the individual components together, testing as a group. So you're doing like component by component usually with this one. And then this is where everything has been integrated and you test everything at once everything's like integrated. Volume testing, again, this is where you try to push the performance boundaries. Whether like you typically throw a lot of the users at it, maybe you're trying to do things really quickly. You see this in game programming. Sometimes it's a part of the beta testing. When you like, they'll add a whole bunch of beta testers at once just to test the stress limits, right? That's volume testing. And then user acceptance. This is like one of the drawbacks, I think, of waterfall. It's like, okay, now it's mostly done because you don't go back, right? You're just testing after the thing you've implemented. Well, what do they call it? You've constructed something, now you're testing it, and you're testing like pretty much the final product in a pure waterfall and seeing if the users like it. Anyway. Okay. So yeah, unit, again, they say individual units of the system. They're trying to avoid talking about, like, it comes down to, like, I don't want to say line by line, but it's usually method level or function level, individual functions of the whole program is what you're testing at the unit level. And that's software developers only who are going to be doing that. But then you have more and more, as you go down here, you can see that it gets more and more away from software only to, it's mixtures until you get down to user acceptance. Ideally, like, it's already been tested through all these, so you just kind of turn it loose on the users and see how it works. You don't really need the programmers necessarily involved in that, but and there are actually, to show this, there can be specialized tester roles, right? They didn't write the programming, but they know how to test it. So that's the system and integration kind of like mixed in here. All right. So I'm going to skip some of this stuff. This is the term you want to remember, though. Cutover is that point when you switch fully from the old system to the new system. Okay, so and there's some strategies for that. And there's the whole question of maintenance, whether you do it or not, and how you do it if you do it. That's kind of considered the very last stage of any of these software development processes, is the whole, how do you maintain the software? And they're showing you all the different ways you can do that. Okay, so moving to Agile. This is fun. So usually these are shown Agile. I'm trying to be an American. I'm a Yank, but more and more we're starting. I blame Patrick Stewart in Star Trek. Resistance is futile, right? Because he's British, he says it that way, but we should say futile. As a matter of fact, there's somebody who got assimilated in one of the episodes. It was an American, and they said it right the American way. They're like, resistance is futile. But anyway, drawback of that, though, it sounds like feudal in an American accent. So, like, peasants didn't usually resist back in feudal times. But anyway, it's a big tangent. So, Agile is usually shown in contrast. I said Agile. Agile is shown in contrast to waterfall. So, whereas waterfall is step-by-step linear progression where you don't go back, Agile is iterative. Now, I should say this. Agile didn't come like right after waterfall. There's a lot of different software development lifecycle strategies that were developed in between that kind of Agile's a really, it's, how do I want to present this, what I'm about to say? It could be almost considered cultish. It's kind of like a cult that spreads, and it's got like doctrines, and people try to convert people to it, and that sort of thing. I'm not saying it's the wrong approach to writing software. We'll talk more about this as we go, but let's put it this: people like it so much that they kind of like. It's like me when I saw Cobra Kai early on when it was still YouTube Red. I checked out Cobra Kai, and then I like watched it 10 times the first season because I introduced it to 10 different people and we watched it together. So I was a priest for it. So you'll find a lot of people that when they learn about Agile and Scrum in particular, they become evangelists. That's the word I want for it. And it sounds a little cultish, but in between, you had things like the spiral model, which is kind of like the waterfall, except you go through all the stages iteratively. So iterative, for you guys who aren't programmers, or maybe know the term, maybe you don't from other contexts, but iterative just means repetition. So an iteration is one repetition of something. So if you're writing loops in a program, an iteration is one pass through the loop before you start the top of the loop again. That's an iteration, a repetition. Spiral model, for example, is kind of like, there's different versions. I'm not going to go into detail about the spiral model, but I do have hold on, I think I do have a screen for it though. Actually closed it in between, but I will use the Wikipedia open image for it. You can sort of see how, and this is probably just one particular spiral. There was I think this was developed by a guy named, was it Beam? BOEHM? Or he might have done a slightly different version of this. It might have been him that did this spiral model. It's like a particular person came up with this idea, but you can see how it's like the waterfall, except you circle around and around, right? So here's kind of like the investigation phase, and then the analysis, and you got the requirements, and you got a little bit of design, and you produce prototypes iteratively until you have the final one. So you kind of repeat all the stages over and over again, and that can usually reduce the cost of like doing things, because if you come out with the first prototype and it's not what the users want, that's feedback into the next stage of the process, and then prototype 2 should be closer to what they want, right, and so on. And this has got looks like 3 stages. I don't know if that's the technical. In my mind, spiral is just like you take and this is probably somewhat inaccurate for experts on the spiral model or whatever. I try not to get too deep into all the philosophy on this stuff, but just know the general idea, because again, real life is hardly ever to plan into any of this stuff. So it's kind of like, how important is it you get everything defined exactly the way that people want it? But just in general is what I'm trying to say. The general way to think of a spiral model is that you're repeating the waterfall model, but more quickly, and you're not doing fully all the stages. You're trying to you're taking one repetition as feedback into the next repetition. So usually at the end, you'll have something that has less costs. I want to say it might even take less time. I'm not sure about that one, but it's usually the end product is more like what the users want. All the stakeholders, the users and their bosses and stuff want. That's the spiral model. So that's one example of something that's kind of in between. You can sort of think of it roughly as in between waterfall and Agile. So Agile has aspects of that iterative process, and we'll see how more exactly in a minute. In particular, we'll talk about Scrum, because Scrum is the most common Agile methodology. Agile's a whole umbrella philosophy, kind of. It's kind of a religion, and then Scrum is one. It's like it's the Opus Dei or whatever. It's one particular sect within that religion. Again, that's a metaphor. It's not really a religion. I don't think there's anybody who treats it that way. Religion, right, would be all encompassing aspects of life. This is just for software development. And then extreme programming I don't really know much about that. You can read about it in the book. It sounds similar to me, but Scrum has very, very defined aspects to it that I can go over with you here in detail. Well, not in super detail, but enough detail. All right, so I think maybe I'll start with, this is Scrum right here. Let's compare this to, I did have my own image that I had ready for this. This is showing you, this is a waterfall model, right? This is showing what it used to be like. And you can see how it's not exactly the same words, right? This is a investigation. Analysis and design were the same. This is construction, and then they leave out the whole testing and implementation and stuff. But and then this is showing you like this is kind of like a spiral. They call it iterative incremental model. So you kind of like prototype 1, prototype 2. You can sort of see that's the same idea. So Agile, let's talk about Agile first. There's a manifesto. This is why I say it's kind of cultish. So it has a manifesto. It's very small. I should have this memorized by now, but I don't. And I can't. When I zoom, I always lose where I'm at. Let's go back. Where's my manifesto? Here it is. So this is the manifesto. And of course, this was like a committee of people who got together, a project, a big project, not like an organization project, not like a software project. But so individuals and interactions over processes and tools. So what this means, and if you look down here, it says, yeah, that is, while there's value in the items on the right, we value the items on the left more. So you can go, there is an Agile, actually, I have it right here. This is the Agile website. So you see, you actually have it bolded here. So this it's kind of a reaction. Remember when I said the managers have a lot of control in waterfall? This is sort of like a revolution against that in a way. So individuals and interactions. So the individuals here are the users, all the stakeholders, and the team that works on the project is considered. What you're emphasizing here is the knowledge and abilities of the people working on the project over what some top-down prescription for how things work. So don't worry so much about the deliverables and stuff and the tools that you use. Lean in on the expertise of the people who are creating it. Plus, emphasize a lot of interaction between the end users and all the stakeholders in the project, as between them and the team developing it. There's a lot of interaction. So working software over comprehensive documentation. In the waterfall model, each stage you produce deliverables that are feed forward input into the next stage, including like at the design level. As you're coding up your program, you document it in detail about how it's used. There's a real emphasis on that. Here, it's kind of hard to describe what this means. It's easy and hard because, yeah, let me just do it. Working software means that you'll have the emphasis in Scrum in particular, and Scrum is part of Agile. So you can see how this Agile manifesto line is manifested in Scrum, where what you have is, do I want to get into the details of Scrum right now or put that off? What you'll have, just in a nutshell, is you'll have working versions of the software shown to the users, going back to that first manifesto item, the interactions. You'll share that with all the stakeholders, the end users and their managers or whatever, many times before you're completely done. So you'll have, and think of it this way. Remember the prototypes from the last one? So it's sort of like elementary prototype that doesn't have a lot of the features and then more and more features. You have this there's an emphasis on this in Agile. So you'll develop something that works for the users to interact with, and then they tell you the pros and cons of what you just gave them, and what they like. Hey, this is missing. It needs this. What you've done here is wrong, and that's feedback into the next iteration. The point about this is, even compared to the one where you saw the spiral model, for example, is that these iterations are very quick, and there's a lot of interaction between the end users and stakeholders and the developers, the Scrum team. Sometimes I'm emphasizing Scrum here. There's more to Agile than Scrum, but I really have Scrum in mind when I'm talking about this. So the working software means that when they're given something, it works in some way or another. It might not be everything they want, but it works. That's more important than writing documents that tell them how it works. In other words, it's more important than creating a whole product one time with a lot of documentation about how it works. It's more important to give them stuff that works a little bit more and more and they're sort of almost writing the program with you, if that makes any sense, versus just spitting out something you don't care what their input was and you just tell them you have to use it. This is I'm trying to describe what this actually means. This is saying instead of writing a bunch of instructions that tell the users how they have to use the software, you produce software all along with them that works the way they want it to. That's kind of what this means. And that's, again, this is sort of related. These are all sort of related, actually. The customer collaboration. Customers here would be the people who bought your software, the owners, the managers of the place, and the end users in that place. Think of them all as the customers, and they're working with you to help you build the project all along, instead of like saying out like at the beginning, these are all the things we want, this is what it is in writing, this is what you have to do. If we left something out, too bad, because we didn't specify it. So the fact that you didn't code it up for us is not your fault. Or they've written something in the contract that you can't deliver on. So this is more of like, hey, we're doing this together, versus it's set in stone what we're doing from the beginning. And that's sort of like all these kind of flow, if you notice, like responding to change. So you might, as you're collaborating with the end users, you might find out there's something you need to change. Like all of you had the wrong idea about it. There's something that's cropped up that you can't do. It's not feasible or whatever, or it doesn't work the way you thought it would. That's the whole responding to change, versus like having things set in stone from the beginning. And again, it says you value the things on the roll. What you should still have documentation for your software, whether you did it working with people or not. You should have, choose good processes and tools to develop your software. You got to have contracts, ideally contracts that accommodate this style of development, but still contracts, right? And then you got to plan things. So that's the Agile manifesto, the Agile manifesto. All right, so Scrum is showing like one way of doing this. I'm off the slides now, so we might have to fast forward through it. So let me see if I explain Scrum to you in a nutshell. Do I have a thing that has the roles somewhere? I think it's in here somewhere. Here we go. I'll talk about the roles first. So the Scrum Master is the guy who knows Scrum. You get certificates in this. I see every day with some of my former students at other schools. Like, I just got certified Scrum Master, so maybe I should do this sometime. So there's 3 roles: Scrum Master, the team or the Scrum team. Sometimes the Scrum team's just called the Scrum. There's variations in that last one in particular, Scrum teams. There's variations in names for that. But Scrum Master, usually, I would say it's usually 2 words, but whatever. And then Product Owner. So Scrum Master is the guy who understands Scrum methodology. He's the expert of how to do Scrum, implement it, make it work. And you can see here, he's kind of like the person who's the advocate for the team and the product owner. You can think of all these as one team. It says the Scrum team. So this is why team and Scrum team are, because the Scrum team really is all 3 of these things, all 3 of these roles. Usually it's one role, one person for these 2, and then like a bunch of developers. And sometimes these guys are involved in here. Ideally not. These people should be separate from this, because again, this is the guy who makes sure that Scrum procedure methodology is followed, and he also tries to make he runs interference to the outside world to make sure that they're not bothered in their tasks by the outside world. The product owner is also sort of has that role too. The product owner is the person who let's see how, because I'm trying to decide whether I want to introduce other terms that I'm going to introduce anyway or not. So you have this thing called the product backlog. The product backlog. The product here is the software program usually. So for a nutshell, that's what it means. The product is the program you're writing, or the software you're writing. The product owner is the person who prioritizes things that need to be implemented in it, and that can change from time to time. Again, this is a very quick iterative process. I'm just going to say the traditional, it's called a sprint. and I'll show that here, and I'll show you those terms here in a second. But a sprint is one iteration. It's very quick. The traditional sprint is 30 days. Sometimes it's only 2 weeks. Sometimes it's longer, 2 months, something like that. There's variations on all this stuff, honestly. But the original Scrum idea was 30 days that you work on an iteration of the product. And during that iteration, the priority doesn't change. Everybody knows what thing they're trying to implement. And at the end, you'll have a working product. It might just be like sort of a template UI screen, for example, after the first iteration, first sprint, where you can sort of interact, but you click buttons and they don't do anything, that sort of thing. But it's still working, in quotes, right? The product owner is the person who decides what order things are done on the whole project. And then each month, the team, along with the product owner, figures out which things from that priority list they want to implement in that month, in that sprint. And the Scrum Master, again, makes sure that everybody's following the process. So here's the product owner. Right? So there's more to it than what I said, but I mean, like making sure the product backlog items are clearly stated, so everything had to do with organizing that list of tasks that you want to implement. But this is the one I was talking, ordering the product backlog items to best achieve goals and missions. I guess I said prioritize, like what's the most important thing, but it's really like the order you want to do things in. And that might involve priority. Like we want to make sure this is done first because it's very important. Or maybe you want to make sure it's done last because the other, get the low-hanging fruit, whatever. But the product owner is the person who organizes. The product owner, if you want to compare it to the waterfall, is like the lead of the whole project, right? The person that's the boss of everybody in the project. It sort of corresponds to that. But the thing about Scrum and Agile, it's the hierarchies are sort of like de-emphasized. So there's not so much like my boss told me to do it and I have to do it kind of thing, right? It's more like, I don't want to say communist because I like it. I kind of like Scrum, but it's more of equitable. What's a good word that's not loaded? Democratic, I guess. But yeah, there's less that. I mean, obviously, think the Scrum Master might be the boss, or the product owner might be the boss, but they're really just there they're almost meant to like serve the team, so the team is unimpeded in their tasks. The philosophy there. So the product owner like takes care of all like the organization of it, so the team doesn't have to think about that. And the Scrum Master takes care of the process to make sure everybody's following the process. And he runs interference. So you see how he's organizing the meetings, removing obstacles, the impact. So this might be a typical thing that happens is in the middle of developing anything, whether it's waterfall or not, somebody will come, an end user or whatever, like, hey, I had this idea. You really should do this. Or like the boss comes and says, we had a meeting and we decided this has to be in the program, whatever. The Scrum Master ideally will say, no, not this iteration anyway. I'll take this to the product owner and we'll discuss it, and the product owner will decide whether or not it goes into the project. I mean, maybe he's forced to because his boss is like, this has to be implemented. But even if it has to be implemented, the product owner says, okay, I'll put this in at this point in the product backlog. But my team is not going to deal with this until the next sprint starts at the earliest. So I don't know if I'm going into too much detail here, but I think it's probably time to talk about this. Let's go back here too. So this is the product backlog again and this is going to change. If you notice, there's a line that goes all the way back here. So the product owner will figure out what the product backlog should have on it, and then the whole team, Scrum Master, product owner, and the team the programmers, the Scrum team, well, the team of programmers will get. By the way, Scrum comes from rugby, right? If you guys know what a Scrum is that how it's kind of like the kickoff or the tip off. I don't know much about Scrum, but I know it's like they throw the ball in the middle of them, and they're all linked arms in a circle, and they kind of kick the ball out, and it goes to somebody outside the Scrum. I don't know. But the idea is you've got a bunch of people kind of linked together working. That's the idea of a Scrum, to get things started. I don't know, whatever. Look it up. But anyway, so a sprint is one iteration. And again, traditionally it's 30 days. It's a month. It could be shorter or longer depending on your individual style. But traditionally it's 30 days. And the idea of a sprint is it's an atomic unit. If you remember, we talked about atomicity, I think, in transactions and stuff before. Think of it as unbreak. I mean, it is broken down, obviously, but to the outside world, it's not broken down. So these are like the quarks and protons and neutrons and electrons and stuff to the outside world. But the idea is that once the sprint's planned, you create items, usually items from this will be incorporated here. So we're going to do this thing, this thing, this thing, whatever, in this planning, this meeting from the team, the whole team. These are the items we're going to do. And then the team will figure out who does what. Because another idea about a Scrum team, or the programmers who are writing the code, not the Scrum Master, not the product owner, though they might be involved to some extent on this, but the team figures out. It's called self-organizing. They figure out who's best to do what. The idea is also cross-functional. Let me make sure I'm right on this term. I think I know what it means, but okay, yeah, I think I've got a fairly good grasp. So cross-functional is the idea of a bunch of different people from different areas coming together or work together. But it's also the idea in Scrum is that cross-functional, usually people on the programming team will have all of them will have many different areas of expertise that overlap even. So this guy might be good at this particular thing, like maybe writing user interfaces, or designing it, implementing user interfaces, coding them up. And another guy might be good at that too. But then there's another guy who's good at the back end stuff, and nobody else is really good at that. But ideally, all of the people on the team will have various, they won't be specialized. That's what I'm trying to say. They'll be more general. They might have their strengths and weaknesses. And the whole point of the way that Scrum teams work, again, Scrum team is the everything, but it's also, I'm talking about the programmers. Ideally, people will have different strengths and weaknesses, and they figure out together as a group, as a team, who's good to do what this sprint. And they self-organize. So nobody's coming in to tell them what to work on. That's the whole point. Again, waterfall, you're assigned duties. Like, we'll get this person to do the UI, we'll get this person to do the back end, we'll get this person to do this or that, whatever. You're assigned those duties, and it might change as you go a little bit. Like, oh, we found that this person's better, whatever. But a Scrum team is built in. The whole idea is that nobody's telling them what to do. They're like, hey, I'll do this part, and you do that part, and like, Joe's good at this or whatever. And you all figure out, the decisions are made at the team level, not at the management level. It's the whole point. So again, let's talk about this. This is the sprint. You got the product backlog. That's for the whole program, for the whole software that you're developing. Every month you'll plan the next sprint. You decide what items from the product backlog should be on it. The team will figure out who does what. And then each day, and again, this is like the religion part. It's like mass or something. I don't want to single out any particular religion, but I'm just thinking of different ceremonies that are had in different religions. Like certain times of day you might pray or whatever. Daily Scrum has one of these. So before the workday starts, you have something. And again, this is traditional. It's not always done this way. Just like Waterfall's never perfectly implemented, Scrum has variations of this. But there's something called the Daily Scrum. And it has different names too. The Scrum meeting, the stand-up sometimes, because I don't know if this is folk etymology or not, but like, stand-up to me means like kind of propping something up. But they're saying because you're usually standing when you do it, because the whole idea is a Scrum meeting is fast. It's 15 minutes is the time limit traditionally, and I doubt that ever happens. And the way it works is the product owner, the Scrum Master, and the development team come together. And each person, particularly the ones on the development team, will state three things. This is part of the, what's the word? It's not catechism, is it? Like the call and response or whatever. I keep comparing it to religion, but they'll state three things. This is what I did yesterday, just in general terms. Like the last thing this is what I've accomplished so far, basically, since the last time we had a meeting. Whenever that was. So let's just call it yesterday. So this is what I did yesterday. This is what I plan to do today. And these are the things that are causing me problems. These are my obstacles. These are the things I think are standing in my way of doing the things that I need to do today. And each person does that. And then ideally, the Scrum Master will take this information and go try to iron things out. Like maybe the team's working inside of a bigger business, right? So it goes and maybe tries to iron out things with people outside that are causing them problem. Whatever the problem is, I need paper or whatever to sketch things on. Maybe the Scrum Master takes care of that. And of course, the product owner probably would give feedback about what items in the sprint backlog should be worked on or whatever. So they do this for a month. Again, that's the standard. There might be variations in that, but the sprint will last for a month. And then at the end, the deliverable will ideally be a working product that the end users, and again, what I should say about the daily Scrum, what I told you, the people who are at it are the essential. You can also have people from outside, other stakeholders, like the end users or stuff, or the managers or the bosses can attend these meetings too. But in a pure Scrum meeting, they keep their mouths closed and don't interfere. They just listen because the user involvement's important. They might want to know what's going on in the development, and it's good for them to hear. And then they can talk to the Scrum Master to like voice concerns or whatever. So the Scrum Master kind of goes back and forth between the team and the outside world. But yeah, ideally, I'm sure this never happens, or maybe it doesn't always happen. But like the attendees at the Scrum meeting can just observe and listen. But I bet they pop up sometimes, and they shouldn't. But anyway, especially the bosses, the managers. So that's the Scrum meeting, and you develop a working product at the end, and then it's reviewed by all the stakeholders, ideally the users. Like say, they'll try it out and say, this is what we need, this is what's not working, whatever, but it'll be, the idea is that you do this every 30 days, and the product will grow over time to have more features. And the idea is that because you have these frequent feedback loops, that the product you're getting is improving over time in an exactly correct way, and as opposed to like something that's full of features you don't need or whatever, things that don't work right. So that's kind of the general idea behind Scrum, and I think I don't really need to go too much more detail. You can read. There's so much to this. I'm trying to give you like the nutshell about it. So yeah, increment. I don't call it the increment, but that's a good idea. So each time, but I do have a good picture to show you what I just described. I think if I can find it, I might have to hold on. Let me pause. It was right here on this first tab. I didn't. So again, Scrum is a methodology within Agile. So this is just calling it Agile right here, but this is kind of the idea. So this is the stages of a Scrum project for each. You can think of this as the increment from a sprint, right? You got a canoe, cross the river from it. The user's like, well, but I need to go faster up and down the river. So you get, what is this called? A jet ski. And then, I need to be able to fit, so like something more capacity so you can like fish or whatever, and something that can handle the sea, right? And then I need to go across the ocean. So this is compared to waterfall, right? So the idea here too is like, I don't think this is, I mean, the idea that the sentiment is right? The sentiment's right. I don't think you can directly compare it because you don't actually get, the users can't use this. The users only get this. That's what I'm trying to say. They don't get this, but this is how you have to build the thing, right? You do a little bit at a time until you're done. And it's only going to be one thing the whole time. It's always going to be this. The thing here is this could have been this. You see how they're the same, but this could also be something that looks different from this, right? This will be a submarine when they really need in waterfall. You might produce a submarine when they really only needed this, for example, or maybe they need a submarine and they got this. So this is it's a funny picture that kind of gives a nutshell of like how people, especially people on the Agile side, see waterfall, right? I wouldn't strictly go by this, but it does have the general idea of how you compare the two things. I thought it was it's a cute slide. And this shows like the thing I just showed you, So I like because this has got more detail right here. So this is the product backlog. They've got, sprint. They don't show the sprint backlog in here, I don't think, but the daily scrum every day, and then however long the sprint is, and then then you review the sprint and see. That's the whole, like, the users looking and trying it out and giving feedback, and then you take all that feedback and go back to the beginning. So so pros and cons. There are pros and cons for it too. So and I almost left this out, but I wanted to make sure I include it. So I don't know about the intense process that can burn out system developers and other. I don't know if that's true. Like, it seems like waterfall would also be prone to that, but whatever. So documentation is produced as a byproduct of. So this is what I was saying about. As long as you're, like, talking to the users as you go along, you kind of develop documentation together instead of developing the documentation and saying, this is what you got to go by. Too bad if you don't like it. It's sort of a organic process of developing the documentation as you go. I don't know if this is actually true or not, but this is the biggest thing I wanted to talk about. It does make, with waterfall, you talk to the users maybe a little bit at the beginning and maybe not even all of the users, and then at the end, the users take what you produce, right? They don't invest a lot of time and energy and thought into it. But here, Agile is like, it's essential that there's a lot of back and forth between the people you're developing the thing for and the team that's developing it all along the way. Like, maybe even every day. I don't know how often bystanders show up at Scrum meetings in the morning for 15 minutes or however long they actually are. And I'll say this too, Scrum kind of came out of the software world. So, like, waterfall came into the software world from, like, manufacturing, right? Scrum was sort of like a reaction to waterfall, loosely speaking. I don't know how true, or there's some truth to that. I don't know how much truth, but I want to say there's quite a lot of truth to it, actually. What Scrum, Agile methodologies in general are a reaction to the rigidity of waterfall. Then that was taken, and people outside of programming and software development do Scrum type stuff now. But yeah, it takes a lot of the time of the people, the stakeholders, the end users, the people who are actually developing it, the code, the people who are not on the Scrum team, those people who are not on the Scrum team, but whom the Scrum team talks to, are a lot more involved. So that might be a burden in some organizations, businesses. All right, DevOps is another, that's new to me, so I'll let you read about it in the book, but not even sure if it sounds a lot like Scrum to me, just like kind of looking at it briefly, but I think it says IT and development together, because IT, again, it's not necessarily, IT is not programming necessarily, right? But programmers have to use a lot of IT stuff, so maybe that's one aspect of it, getting more of the non-programmers involved. I don't know. You can read up on it on your own. And I think that's all I want to talk about. That's near the end anyway. Those are because I know a bit about Scrum, so I wanted to share what I knew. Scrum in particular is what the thing I want to talk about. And again, it's sort of a religion. There's more to it too. There's, like, what are they called? User stories is a big, the way you plan things. How you have the UML diagrams and ER and data flow diagrams and stuff in Waterfall. And it's not like you don't have those things in Scrum. But there's another thing called user stories, which are like, it's kind of hard to describe. Let me see if I can real quick. I don't want to leave out, like, a big component of Scrum. Like, what I showed you is the core of it, but, like, some of the ways you approach each of those steps. User stories is one of the big things. So, Atlassian, if you guys are familiar with that, they have a GitHub, what's it called? A GitHub alternative competitor, right? This is not really showing. I know there's a lot of, like, post-it note type things or whatever. So agile modeling, right? This is the design stage if you're comparing it to waterfall model. I want to say there's some really good, here's the cards. So like, as a student, I want to purchase a parking pass so that I can drive to school. And then, so that's like one user story. So, whatever. You get the idea. It's one of the methods for the design stage of a Scrum project. And it's a big, there's like all kinds of off the shelf software you can buy to like organize this stuff. Anyway, I'm trying to remember exactly what user stories is, but that's enough to know about, because you're not going to be tested on that, by the way. So, but it's enough to know that it's a part of the design process. It's that whole like interacting with the end users to get what they need kind of thing. But it just sounds ritualistic again. Like that's what I'm trying to. There's this whole undercurrent in Agile and Scrum of like a cult. I'm sorry to say, like that's a miss. Maybe I'm me and other people who, and I like Scrum, but like that's the way I would want to do projects at least. I mean, I've done a little bit of Scrum in the past in real life, but not a whole lot. I do prefer the idea, just in the ideal of it in my mind is better. It's a better way of doing things. And I will say, if you look at the statistics, it is more successful than waterfall in most of the studies I've seen. Like failed projects versus not successful projects, it tends to be that Scrum does win out on that. So I think it's better than waterfall anyway. But it is, I mean, you have like the priestly cast, right? Like you've got the Scrum Master. So Scrum credentials is kind of like, it's almost feel like a Scrum Master should have like something like Rev in front of their name, the way it's sort of like presented. But I don't want to, I don't really, it's got cultish aspects to it, but I'm not saying it really is a cult, and I'm not saying it's a bad thing. I just want to say that I am a believer in Agile and Scrum in general, but but I'm just warning you, and maybe I've biased you by saying this, but for you people who have, maybe some of you have experience with Scrum already, and maybe give us some input. I should put a discussion board up on the topic. I need to have another one soon anyway, where people can discuss what they think about Scrum. And this is how I would like do the question, like, what do you think about Scrum versus Waterfall? What are the pros and cons? And then people, if you've done Scrum, if you've been in Scrum teams of any kind, whether it's programming or not, what your thoughts of Scrum are. But don't want to emphasize this too much. I just think it's an interesting topic, so I want to talk about it. Anyway, if you have any questions about this material, send me an email. And again, exam 2 will be soon, because this is the last chapter in the exam, the part 2, the exam 2 part. You should have a Python program due not too far from now. If I do use this in future semesters, this is probably right before midterm grades are submitted, and which will be based up through probably week 6 at least, maybe week 7, but definitely including exam 1. But it's probably right before spring break for most semesters, so have a good break. I'm trying to minimize the amount of work you do during spring break. I'm assigning this, but the work for this won't be due in most semesters until after spring break. So check the calendar just to be sure when everything's due. And take care.